Okay, class, today we're going to look at simple and compound interest. And this is part of going over with budgeting and stuff like that. So it's going to deal more with your bank account so that you can budget on how to save, look for the best deals out there, and so on and so forth. All right, so simple and compound interest, we're going to start on page 73. And today's date is the 5th. So go ahead and turn to that page when you get a chance. And there it is. So simple and compound interest. We're going to first talk about simple interest. Simple interest is the interest that's paid only on the principal and is paid out of the person who owns the account. And a principal is the money you put into a savings account. A lot of people say it's like your starting off money. It's what you're putting into. So if I put in $1,000 into a savings account, I'm hoping that savings account that I never touch it, and the bank has a decent interest rate on it so that over time, a certain period of time, I can earn money on it. Okay, so the principal is the money you're putting in. The simple interest is a rate that over time can earn you some more money. All right, so the formula to calculate simple interest rate is I, which is your interest, equals P, your principal, the starting out money, times the rate, which is interest rate, and you'll change that percentage to a decimal, and then times the T, which is your time in years. Okay, so that is your I equals P times R times T, principal times the rate times the time. All right, so we're going to go ahead and dive into an example because I think it makes more sense whenever you deal with money to have money. But here is your first example. So say you deposit $100 into a savings account with an interest rate of 5%. You want to know how much it is after 2 years, or how much interest you have earned after 2 years. Okay, so you put in your formula, I equals PRT, and your interest equals your principal is $100. That's what you're depositing into the savings account. Your interest rate, 5%. So we're changing that to the decimal 0.05. Remember, percent to decimal, we move 2 times to the left. And then over the years, 2 years, that's what we put in for T. So we have 100 times 0.05 times 2. I went ahead when I did my multiplication because we talked about the commutative property that you can, anytime you have the same operation, you can multiply any sort of way and you still get the same answer. So I went ahead and did my 100 times 2 to get 200 first. So I did my whole numbers together to make things a little easier. Then I decided to multiply by my 0.05, my rate. And at that point, I got 1,000. The 0.05 having 2 decimals, I get 2 decimal places in that answer. So therefore, I have 10 as my answer, 200 times 0.05. So the interest that I have earned is going to be $10. Okay. The total amount after that would equal then total amount, and I'm going to put, I didn't give myself room. Let's say total amount after or earned is going to be $110. Okay, so total amount earned is $110. That is if you have not taken any money out. Okay, you got to leave that money alone in order to gain that money. Okay, doesn't seem like a lot, but I'm telling you, after a period of time, and if you put a good amount of money into it and you add money to that, you don't take away, but you add money to it, this $10 can become thousands of dollars in a short period of time. But that means you're not touching the money. Okay, we're going to look at more examples of simple interest rate whenever you get in class tomorrow, first period. So if you need to go back and pause video or go back and finish up from the beginning of this, you can. I'm going to move on to compound interest. Okay, and the compound is a little more complicated. Compound, meaning you're putting more than one thing in at a time. Okay, and this really relates to the time. Okay, so interest earned is kept on deposit to earn more interest. This is computed on the entire amount in the account, including the principal and any previous interest earned. So this is over a period of time, and the interest earned is added into what is already there at the end of that year. And then that next year, that interest is now computed on what has earned the previous year as well. So it just keeps building and building and building. And this is what most banks use. Okay, so the formula to calculate compound interest, what you're earning, is A, which is the amount in the account after however many years, if no withdrawals were made. P is still your principal, your original amount, or what you put in, times 1 plus R, which is your interest rate again, and we're going to change that percentage to a decimal. And then T is an exponent now, and that is your time in years still. So your letters still mean the same thing, PRT, principal, rate, and time. You now have the amount after so many years, what you've earned after so many years, whereas the I was just what you earned for that 1 year. Okay, so we're going back, we're going to use the same numbers with our example, but this time we're going to add more years to it. And so we have deposit of $100 with an interest rate of 5% compounded annually. Okay, this is key. If it doesn't say compounded annually, we're going to assume it's simple interest. We need to know that it's compounded. So no withdrawals were made. What is the amount after 5 years? Okay, so with that, we put in our principal, which is $100. Okay, I didn't mark that, so I'm going to go ahead and mark principal is $100, and our rate is still 5%, so we're going to change that to 0.05, and then our time now is 5 years, and this is compounded annually. That is important to know. Okay, when we plug our numbers in, okay, yes, you have to do the exponent first. Hopefully it's not going to be as complicated as this every time, but it very well could be. You just never know. So 1.05, because 1 plus 0.05 is 1.05. Okay, to the exponent of 5 or to the power of 5. So 1, 2, 3, 4, 5. I did use a calculator to save some time, and you're more than welcome to do that. In class, we may take one opportunity to actually work out the mathematics of it. But to save some time, I used a calculator, and after I did 1.05 to the 5th power, we get 1.2762856. So since we're dealing with money, I only need to go to the hundreds place value because that would be the 1 cent with money. And therefore 6, 5 or more raise the score, raises this 7 to 8. So when I plugged it in back into the formula, I have my 100 as the principal times the 1.28 or $1.28. Okay, and when you multiply that, you get $127.63. This is rounded. I believe it says 62 after this multiplication, so I rounded it to 63 cents. Okay. In order to know how much interest you've earned over that 5 years, you need to subtract 100 minus the $127.63. This gives you the earnings. So after 5 years, the amount earned is $27.63. Okay, and that is what A would equal. So actually, A is not $127. That is what you've earned over 5 years, and what would be then if you did the 6th year. This amount would then get compounded it would get then multiplied by the percentage and all that kind of stuff. But the annual amount that you got is $27.63. Okay, again with the simple compound interest, simple interest rate. We will do more of this in class. This is going to take some time to get used to and to understand. It is very important that you come prepared tomorrow, first period, to talk about these problems. We'll do many examples over this in class. So be ready to know what the difference is between the simple and the compound interest rate on money.